So we're known for developing this expandable solar roof rack that can go on top of Teslas, any electric vehicle, hybrid, van, whatever it may be. My name is Omid Sadekpour, and I started Dart Solar because I bought an electric vehicle, a Tesla, and it was baking in my driveway. So as I'm developing the product with a team of engineers, I figured I'll document it so that anyone that's thinking about product development, business decision making, can watch this channel and follow this channel so that you can better understand the decisions we had to take. I hope the background is to your satisfaction. Dart Solar is half engineering, half design work, so I figured the background could embody both things. In this particular video, we're going to explain why we decided to move forward with 3D printing as our main form of production. So for example, when you put the Dart Solar on top of a Tesla, this piece of, we call it a feet, goes on top of the rooftop of the Tesla, and it actually holds the solar panels. This is 100% infill 3D printed. It's pretty heavy and it can sustain a lot of weight. Now, this has not been sort of post touched. This other version that I have here, you can see it shines. This is because it went through an acetone bath and it actually finalizes the 3D print. So what we did to test how much weight in compression and in tension the feet of the solar panel can sustain. I mean, that's a very important uh, test we need to make sure that the solar panels don't fly off your vehicle. We put the feet through some very rigorous testing. Before I show you the results of the test, let me explain to you how it all works for the people that are wondering, how does a Tesla roof rack work? So here I have, or any roof rack in general, but specifically a Tesla one. So here I have a J hook that basically goes under the glass of the Tesla, right? So the glass would be here, your roof glass. This goes under the glass, and Tesla has created a mechanical structure by which this can go in and hold onto the frame of the vehicle. Then this J hook goes through a rubbery shoe. We call it a shoe, but you call it whatever you want to call it. This J hook goes through that. So basically, this shoe lies on top of the paint of the frame of the vehicle. And that's how the standard Tesla roof rack also works. The nice thing about the shoe is that it's made out of rubber, it flexes, so it really takes care of the paint and the shining on that roof rack area. The shoe goes through, the J hook goes through the shoe, and then the J hook goes into the feet, like so. You can see right back here. Oh my gosh, I probably broke my laptop. And then this nut goes into the J hook. Now, that prevents the roof rack from exploding upward, right? But we also want to make sure that the feet themselves do not break. Now, we have a locking mechanism. So then there's a lock and a structure that goes in to prevent anyone from opening the nut to be able to lift the roof rack from the vehicle. Fantastic. So what did we have to do to test this? First, we put it in an acetone bath to add structural integrity to the external frame, the external filaments of the 3D print. Now, this is the one that we tested that broke. So you can see here, this is how it looks internally. It's 100% infill, no space. This helps a lot with compression and tension. So what we did is we took a feet, we loaded it, as you can see on a video that I'm going to put here next to me, and we just tried to expand it, right? Put some tension on it. And to our surprise, it could sustain a remarkable amount of tension. I think it's around 600 pounds in this device that we created. So basically, the way that the device works is that there's this gigantic wrench that one of our engineers is driving. His name is Thomas. And it turns a gigantic bolt. This bolt goes through a nut that basically is connected to the bottom of the feet, and it was basically pulling this feet as it's rigidly connected to the structure, to the jig that we have developed. In this video, you can see that one feet can hold a tension of about 600 pounds, which basically means there's 4 feet holding the DartSolar on top of your vehicle. This basically shows to us that your vehicle's roof is going to break before the 3D printed 100% infill plastic that's holding the solar panels is going to break. For us, this is a phenomenal result because in the overlanding and the camping that a lot of our customers do, it's important to make sure that nothing can damage the roof rack, regardless of the speed or the bending that a vehicle might go through. But anyhow, I hope you enjoyed this analysis. We're basically going to do a lot of different videos documenting speed tests, aerodynamic tests, acoustic cabin sensing, and lots of more engineering stuff. In our production, we are including 3D printing. And so in the next videos, we're going to cover everything from how we 3D print to the CECing that we do. We're going to do some more tests, and I hope you enjoyed this video. Now, for anyone that got this far, I'm going to show a little bit about myself so that you can better understand how we finance and bootstrap DartSolar. DartSolar is completely bootstrapped. We did not go to investors for the early prototyping. I finance all of this because of a software company that I started 7 years ago, and there's a team of people that helps us. And I can talk a lot more about it, but really the focus of this channel is going to be the engineering of the DartSolar. But the other company, in case you're interested, is called UExec. It focuses on developing business strategies and frameworks for Fortune 500 companies. Although we have a whole variety of customers, we really focus on taking a business framework and putting it in a presentation form, like a PowerPoint or a spreadsheet, so that managers all over the world or entrepreneurs, founders can use the material. A lot of the work that we do involves in innovating for our customers. We do a lot of consulting to innovate products for the Fortune 500 companies sometimes. And DartSolar is kind of like one of those weird things that I was brainstorming with people, and I saw my car baking in the sun in the driveway all the time. And that's that. So I hope you enjoyed the video. Till next time, talk to you later. Um, I apologize. Yesterday, I forgot to finish the second test we did. Um, this is the back feet of the DartSolar, and it can withstand a tension of over 700 pounds. So I'm going to add the video for the test here. And the reason it can withhold, it can have over 700 pounds of tension is because, first of all, this goes in the rear of the vehicle. So the rear of the vehicle has two of these feet side by side, and the front feet are the ones that have the curved top. This is also a 100% infill print, and we put bolts through the fully printed model. That way, when the J hook goes through the bottom, right? J hook goes through here. These bolts are going through the entirety of the model, like so, right? So there's a metal connection that connects everything, and the frame of the DartSolar is on top of the top portion of this feet. So basically, with the back feet and the front feet, you could literally lift the car. Most vehicles, you'd be able to lift most vehicles from the DartSolar, and we would know that at least the feet that are holding the frame of the solar panels are not going to break. The frame itself is a 1/8 inch aluminum square tube 6061 alloy, which is pretty strong. We've also stopped testing it after 500 pounds of stress. to make sure that the frame is very strong as well. In the next videos, we're probably going to start talking about telescopic tubes. This is a 3D printed telescopic tube. We use aluminum, custom extruded aluminum telescopic tubes that we've developed, but we're going to explain how the telescopic tubes help us expand and contract the solar panels so that you can capture as much sun as possible and charge your vehicle. Thanks again. Catch you next time.